I don't like it when it's
What did we do last time, people? Concentrate.
unfortunately we have half the time.
Concentrate. We are actually doing something more complicated. We finished doing derivatives. Your exam was on the derivatives. Now we're doing integration. We learned some kind of integrational rules. And actually, I collected them over here. Today we're going to learn more. We learned the basic one. Integral of the empty part, which is 1, is just x. Because derivative of x is 1. But you add plus c, because derivative of c is 0. So when you differentiate, derivative is unique. But when you integrate, you have to add plus c, because it gives you a family of solutions versus a unique solution. Then we learned how to undo power rule. When you integrate x to the n, you add 1 and divide by that same number, n plus 1 over n plus 1 plus c. The exception is when n is minus 1. When n is minus 1, x to the n becomes 1 over x. This is the case that gives you natural logarithm of absolute value, because derivative of log is 1 over x. You can always check yourself by differentiating. Derivative of e to the x is e to the x, so integral of e to the x is e to the x plus c. And today we're going to cover sine and cosine. There are more things over here. We don't cover all of them in this class, but for engineers and math majors we do. We cover arcsine, arccosine, arctangent, arcsecant. So at least we need to know sine and cosine. Let's do that. Tricks. So you have this in our notes. It was at the very beginning. Here they are. And then just by knowing the derivative of sine and cosine, you can tell me the formula. For example, sine. What is, so integration sine is beautiful long s, sine x dx. What is the integral of sine? In your mind, you should think derivative of what gave you sine? Cosine, but negative cosine. Derivative of cosine is minus sine. To fix a negative part, you should multiply by minus in front of it, plus c. So you can always check by differentiating. It should give you cosine, minus sine gives you sine. Then when you integrate in cosine x, what gave you cosine when you differentiate? Sine. No negative sign is needed, plus c. So these are good enough for now. We just need these. However, we also will teach you use substitution soon. And these are very nice shortcut general examples of in general case, if you have integral of sine with a linear function inside, ax plus b dx. So again, notation of integral. Integral sign starts the integration, dx says where the integration is done. So whatever is between these two, this is what you integrate. So how to integrate sine with the linear part inside? It will be minus cosine, just like we agreed, but then divided by the leading coefficient a plus c. So let me highlight it. This a, leading coefficient standing in front of the x, you're dividing by this slope. You can see it as a slope as well.
Slope means the derivative.
No, I would call it leading coefficient, ax plus b. But it is slope from the physical point of view.
But what is more complicated? Like,
yeah, if x squared, no, it doesn't work.
It doesn't work.
It works only for linear. Yeah. So let's do this one, cosine. Guess what happens with cosine? Ax plus b dx will be, you say it like this, okay, integral of cosine is sine because derivative of sine is cosine. So it's going to be sine, copy the whole thing, and divide by the leading coefficient a. We will explain you this in the next chapter, actually next week. Leading coefficient. Those are nice shortcuts. I have a whole YouTube video about this. I will send you shortcuts. So let's practice these formulas and then go do some applications. So you can tell your parents that you learned how to find velocity and acceleration from today, which is nice. Yes? Questions? No? Examples. Okay, if you pay attention today, you should be very smart. If you actually pay attention, you can do it right away. For example, integral. Let's find integral of 4 sine of 3x dx. Last time we learned, if there is a coefficient in front, you can kick it out or it just stays. For example, you can rewrite it and kick it outside of the integral. So 4 can be kicked out, but 3 cannot. Because it's inside of the sine, it's part of the angle. Now, we just learned 4 stays. Integral of sine is cosine or minus cosine? Minus. You can always check by differentiating cosine. Minus cosine, copy the part inside, and divide by the leading coefficient, which is 3. Which is 3? Plus c. Don't forget plus c. Plus c shows up because when you differentiate c, it gives you 0. So the answer is minus 4/3 cosine 3x plus c. This is the answer, and we're going to check, just like in last class, we're going to check if it's correct, but I want to wait for a second. Agree or it's weird? The integral of sine is cosine, but with minus. Copy the part inside, divide by the leading coefficient. Leading coefficient was 3, dividing by 3. Let's check. I will change the color. What do you mean by checking the answer? Who remembers? Find the derivative of the answer, and it should give you what?
The antiderivative.
The part inside of the integral. Yeah? So the part inside of the integral. So I will differentiate minus 4/3 cosine 3x plus c prime. I'm doing it because we just undid differentiation. So if I do differentiation right now, it should go back to the part of the inside of the integral. Let's see. Minus 4/3 times, how would you differentiate that? We did it on exam 2 and 1, yes? 3 comes out, right? This 3 comes out, why?
Because of the chain rule.
Chain rule, your favorite rule. Chain rule says copy the function. No. Find derivative of cosine. What is derivative of cosine? Sine or minus sine? Which one? Negative sine. Remember that. Derivative of cosine is minus sine, and then I teach it like this. Times derivative of the function inside. So times 3 plus 0, because c is a constant. So 3 cancels out with 1/3, minus cancels out with minus, and it gives you 4 sine 3x. I hope this is what we have inside of the integral. 4 sine 3x. So it matches.
Wait, shouldn't it end up becoming -4?
Let's see. -4 is here, but then derivative of cosine is minus sine. Minus and minus.
I didn't notice.
Makes sense? So you always can check. It's nice, convenient on the test that you can always check yourself. If you have time, of course. Second example is, let's integrate 5 cosine x minus cosine 5x dx. You see, I don't even put brackets inside. I see that the integral sign starts integration. Dx tells me where the integration is over. So I will not kick out 5 outside this time. I have difference of 2 functions inside of the integral. So I'll do it piece by piece. Integral of 5 cosine. Who knows what it is? 5 cosine. Just yell. 5 sine. How do I know? Because I'm teaching it. No. Because derivative of 5 sine is 5 cosine, right? If you differentiate 5 sine, gives you 5 cosine. In your mind, you always just check very fast. That's how you calibrate the negative sign if needed. Minus cosine is a bit tricky, so minus keeps the minus. The integral of cosine is sine. I will put even like this. Sine, copy the part inside, and then what happens with 5? Divide by 5. So it's good that you mentioned multiply. Chain rule happens when you differentiate, then you do times 5, times the leading coefficient. But when you integrate, you're undoing it, so that's why you're dividing by 5. Divide by the leading coefficient to undo chain rule. Something is missing?
Well, we can see.
Plus c. Thank you.
Sorry, my bad.
And this is the answer. We can rewrite it nicely, but you don't have it. So I agree with all the signs or not? Integral of cosine, yeah, looks good to me. You can always check if you want. Differentiate. 5 sine gives you 5 cosine. When you differentiate sine, minus sine 5x over 5 gives you minus cosine 5x times 5. 5 cancels out 1/5. C gives you 0, matches. So if you say it pretty fast out loud, it works well. Now we know all the basic derivatives. That's actually all. I told you there are more here. But people usually know the integral of secant squared is tangent and cosecant. People don't know cosecant. But people do know integral of secant x and tangent x is secant. How do we know it? Because we remember derivative of secant is secant tangent. Most of you will I don't remember this, which is fine. It's part of the American education, not very international to be honest. But in American universities, they do push these formulas quite a lot. Because again, in Europe and Asia, we don't even have secant and cosecant functions. We just call them 1 over sine, 1 over cosine. Yeah. So these ones are pushed here a lot, these ones too. But in this class, it's fine to just know sines and cosines. And it's very easy to check them by differentiating the right-hand side. Now let's do some applications. Okay, finally, let's do some cool applications. And the most favorite one by student applications. The most favorite one that students like are, you actually already know them and you like them, velocities and acceleration, because you're good at it. Usually people like what they're good at. So if we have S of t, which is given as position of an object, we know that. Position, we learned this when we learned differentiation. It's a position of an object at time t, then what is v of t and how do we find it? Who remembers? Differentiate the position that gives you v, and how do you call v? Velocity, thank you. Velocity and speed, surprisingly, not the same thing. One will have negative sign, the other one is not. You cannot say I'm driving with the speed minus 55 miles per hour, so one is always positive, while velocity can be negative. So it has different ideas here. Same with position and displacement. Displacement is always positive. I went here to the left, then I came back halfway through, and then I was keep going. Displacement shows me only difference that I walked from the table to here, which is positive, but position can be negative. So that's also a pretty interesting idea. Velocity of an object at time t and acceleration. How do you find acceleration? Yes, you differentiate the velocity, very good, which is second derivative of the position. So we learned this before. Guess where all this is going? If you differentiate position, it gives you velocity. If you differentiate velocity, it gives you a second derivative. You're actually finding second derivative of the position, and that is called acceleration. And there are more functions. If you remember, the third one is called jerk. So there's lots of memes about it. Don't be a third derivative. And then there's also pop and crack and whatever physicists made it up, and they're very proud about it. So now,
Stop.
what?
Eventually it becomes stop.
Yes, right? That's what I thought. I actually never knew this more terms after acceleration. But how fast acceleration is changing, that's what the next idea. So how to undo this? If we know a of t, how can we find velocity, for example? Velocity will be, a of t is known. So I will do integral of a of t. So how to undo it? To undo, basically going back over here. Integrating a of t gives you velocity plus, don't forget c, that's important. And we're going to call it c1. And then integrating velocity with respect to time t gives you position but it can be differences. Let's call it C2. So that's not new formulas. We're literally just undoing what we did before. Idea is exactly the same. There's nothing new here. So let's practice doing that.
Is there a way to draw second integral? Is there a way to
Find C?
I mean, is there a format to write that something's going to be the second integral or something?
No. Integral and integral. Good question. No, there is not such a thing. We do integral one more time and one more time. We do have double and triple integrals, but they mean different things.
I was wondering, because you can do that with differential.
Yeah, good question. No, we just keep going. It's sometimes called iterated integration. When you code it in C++, for example, or Java, you just keep going back, integrate.
There was like a accepted format of how to
Yeah. So we are going to do some initial value problems. This is a pretty cool idea. Did I mention this word before, IVP? Probably not, because it usually comes in this chapter, called initial value problems. That means problems. I think I mentioned when we did some related rate stuff. It means some initial value is given. For example, 3 bacteria in the petri dish are given. Only 2 rabbits, and then it blows up in 75, and so on. So initial value usually is not 0, and that's why there is a nice problem here, which starts with the throwing, a rock, like so. You can copy this. I will do print screen. Oh, I will just snip it. A rock is thrown up. It's a very typical example. I see this rock example literally in all the books. That was complicated. A rock is thrown up with the given initial velocity. So initial value is given, and this is the initial value of the velocity. Bless you. Why you guys are sneezing today? Was it some kind of Halloween party and everyone got sick? So the rock is thrown up and the initial velocity is given 50 feet per second from the initial height of 10 feet. Initial height is given. And it has a given formula for the velocity. T is time in seconds after the rock is thrown. Find the height of the rock and the time t. And I will have one more question. So let's call this question A. The idea is very typical. I like showing it with the marker. The integral of this function will be parabola. So the function they gave us is a line. When you integrate it, you will have parabola. You will see that, which makes sense. If you're standing on the cliff and you're throwing the object, you're throwing it up and it goes down. Right? So it is a parabola concave down. And at some point, it actually reaches the maximum, and we can calculate the maximum. If it's perfect parabola, it will be a vertex, but we can do it by finding maximum and minimum, and so on. So, let's see what we are having here. Solution. Let's name stuff. We are looking for, find the height. So, find the height of the rock and time t. Let's go with h of t. That's going to be my height. Why not? And then the height will be a distance, right? Height is distance, displacement, that's the idea. So to find it from the speed, guess what we're going to do? Integrate the velocity. Because that's exactly what's happening. It changes its location. If velocity is given, so again, if the asteroid is passing by the Earth, and some devices could figure out the speed of the asteroid, they just detect it with a speedometer. I want to know how far the asteroid is away from the Earth. That means integrating the speed. So integral of velocity. That means in this particular case, velocity is given as minus 32t plus 50 dt. And that's why this application is extremely important. And we, again, teach double integrals and triple integrals in calculus 3 classes, which is pretty cool. Who can help me to integrate? Minus 32t gives you what? Minus 32, I heard that. And then what? T squared over 2. Agree, disagree? Comments? Let's review the formula. If you don't remember the formula, I write it down. Integral of x to the n dx. When you differentiate and goes down, decrease by 1. But when you integrate, you undo that. So you will add 1 and divide by whatever you got. So from t, it became t squared over 2. T squared over 2. How about 50? What is the integral of 50? 50t. Either you remember the formula that integral of the mt is integral of mt is t times 50, or you just ask yourself, derivative of what gave you 50? 50t. Don't forget plus c. So unfortunately, just like I told you, it is a parabola. It is concave down, and it's looking like this. So it's not starting at 0, 0. It shifted, actually has the vertex somewhere, but it's looking like this. It's concave down parabola. How do I know? Because it has negative sign here, which we actually should simplify. It's minus 16t squared plus 50t plus c.
But we know what c is.
Yes, just a second. Let me explain this part. So we have lots of parabolas depending on c. If c is 100, it will be shifted up by 100. If c is 5, by 5. If c is 10, by 10, and they don't intersect each other. If c is minus 5, it will go down. If c is minus 11, minus 25, minus 100. This is a family of solutions. In this case, a family of parabolas. It's called a family because it just shifted up and down. Shifted vertically, yes. Vertically by c. So if c is positive, it goes up, negative, down, down. But the cool part, they never intersect. Since they never intersect, we can detect the unique parabola we need for this particular case. Because we don't want to have millions and infinitely numbers of answers, I want to know how far the asteroid is. I don't want to have a family of solutions. So how far it is? Is it 5 meters, 5,000 meters, or whatever it is? For this answer, we need initial value. Initial value is when you were detecting speedometer was detecting speed of asteroids. At some point you should say, oh, when it was 1247, at least at this moment, I saw that that distance was 5 meters. Well, that's too close. 5,000 kilometers, right? So this is what's called initial value. And we have it. It says initial velocity is given. And initial velocity makes this problem initial value problem because initial value is 50. But you need to know which initial value. We have two functions here, v and h.
Since v is already in the problem, we need the h, which we also have.
And it's over here. One more initial value is given. Initial height is also given, right? So this is also initial value. Initial value over here. And that's why you should be smart enough to see which one is which. Initial velocity means velocity at time 0 is 50. This is exactly how to describe this phrase. When it was 0 time, by the way, initial not always means 0. That should be described by the problem. Sometimes there are 2 moleculars, so it's going to be at 2, for example. 2 rabbits or whatever. And then initial height. Initial height is h at 0 equals 10. So to find c, which one are we going to use? Height, right? Good job. We don't know c. C belongs to height. So to find c, that's going to be step 2. Let's do it step 1. Step 1, integrate. Used to be step 1, differentiate. Now it's going to be integrate all the time. Step 2, find c using initial value. But you need to learn to know using which one. H at 0 is given as 10. But we know h. H at t. Let me do at 0 right away. H at 0, I'm plugging 0 into the solution we just got. Minus 16 times 0 plus 50 times 0 plus c. We know that. So let me write down. This is given. Change the color, please. This is given This one we found. But it's given that the answer should be 10. So we have 10 equals 0 plus 0, so 0 plus 0 plus c. Solve for c. C is 10. Be careful, it's not always the case. It's just in this case it matched 10, but sometimes it's not. E to the 0 is not 0, cosine of 0 is not 0, so sometimes you plug 0 and not everything becomes 0. If c is 10, you can complete the question. 3. H at any time t is minus 16 t squared plus 50 t plus 10 instead of c. That means this initial value told me, the initial value says when height is at the moment 0, that's my t. Here's 0 moment. Height of my hand throwing the stone was 10, whatever it is, 10. This is my 0, 10. So knowing this moment indicated this unique parabola from all other parabolas. And since they don't intersect, it's only one choice. So this initial value is basically a point on a parabola. Which parabola? That's the parabola you find. So for this particular parabola, c end up to be 10. This is the answer for question 1. Question 2, let's do this. Question 2, find the height of the throwing stone, blah, 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 at t equals 1 second. So how far it went at 1 second? What do you do now? Just plug 1 into your integral, which is h. H came from velocity, if you remember, height. At 1 will be minus 16 plus 50 plus 10, which is minus 6 plus 5, right? 44. 44 units, feet. So it used to be 10 feet at the very beginning, at 0. In 1 second, it's already 44 feet. That's a very fast growing height. So I guess maybe it's a cannon shooting the rock. Does that make sense? We're going to do a harder example right now. So let's try to concentrate on one more example 2. And that's what we put on the exam 3. We put literally this problem with the throwing rock and integration. So definitely, I just put a star in front of that problem. That's exactly what we do. Now, let's do this one. If we give you, instead of velocity, acceleration, then it makes the problem longer. But it's exactly what we like explaining. So, if not this velocity is given but acceleration, we will have to integrate twice. Okay, fine. Example 2. Suppose an object acceleration is given. Acceleration is given as a of t equals 4t. Such a simple formula. You will see it will get into the cubic function, which was very interesting, from such a small formula. The initial velocity is given. The initial position is given. Find the velocity function and the position function. That means we're going to integrate twice, because from a...
Wait.
I will do like this.
Sorry, my brain is working backwards.
Again, let me review it for you, what I just explained before. Let's do like this. S goes to V goes to A through differentiation. But then you can go back by integrating, and then go back by integrating one more time. So those are my integrals. So let's do differentiation, but then integration to go back. Integration and integration. If we're going from A to V, from V to S, so we're going to integrate twice. And we start with the very first function, a of t. Only a of t is given. Solution. When I'm integrating a of t with respect to t, so you call this integral of a of t dt. that will give you a function called velocity. But don't forget plus c, right? So we're integrating 4t dt. That's what's given in that blue box. Do you see? Let me wait for you to copy. Do you need more time? Time is in seconds. A is in feet over squared seconds. Why feet per square seconds? Because it's a second derivative with respect to time. Every time you differentiate, seconds show up. What is the integral of 4t? Who can tell me? Step 1. 2t squared. Very good, you did very fast. In general, you do 4t squared over 2. And then you do it so many times at some point that you just know that 2 cancels out with 4 and it becomes 2t squared plus c. Plus c. So let me review one more thing. The moment you integrate it, the integral sign disappears. So it was integral. We undid derivative by integrating it. The moment I apply the formula, integral sign disappears, c shows up instead. Let's call it C1 because we're going to have several here. Some people call it A and B and C. Some people call it W, W3, and so on. Doesn't matter. C is pretty international notation.
You can solve for C right now.
And now we're going to solve for C. So we need to find, it's going to be 1A. 1A. So it was step 1, now it's 1A. Find C1 using some kind of initial value. And that's why this problem is called initial value problem. So what kind of initial value do we need? Initial value of acceleration, velocity, or distance? Velocity. How do you know? Because we just found velocity. Exactly. This is the function of velocity. It's called v of t. V of t for any general t was calculated as 2t squared plus c1. But hopefully, I don't know yet, so I will scroll up and see. Hopefully they gave us initial velocity, and they did. They said, oh, initial velocity is actually given, and they even were not lazy enough to write down the formula. At 0, it is 30 feet per second. I was like, oh, okay, so we can solve for c1, because now we know that it is given that v at 0, it is 30. So 2t squared plus c should be 30. Then v at 0 is actually 2 plus c1, and it is 30. I'm solving the equation from this part. C matched with 30, c1. Again, be careful, it's not always the case. We're just lucky. C1 is 30. Thus, the general equation for velocity at any time t will be 2t squared plus 30. Put this in the box. This is important solution. Nice. I already can see it doesn't like this. Now, are we done? No. It says, well, you found the velocity, which is good, but this is only half points in the test and half of the problem only. They also asked me to find acceleration. So we found the velocity, and we even found velocity for a particular moment. Now we need to find not acceleration, but distance. To find distance from velocity, we do what? Step 2. Integrate the velocity dt to get distance, which is called s of t. And in this case, it's going to be plus c, so we'll have to repeat the process and solve for the initial value. I know you're crashing, I noticed. Come on. So start integrating and see who is faster. You can do it before me or not. Integrate. What will we get? The function we just got. If you're integrating the function we just got, it's going to be integral of. Yes, I can hear it. Yeah, sounds very good. It's going to be integral of v of t, which is integral of 2t squared plus 30 dt, which is integral of 2t squared is 2 stays because it's multiplied. T squared becomes, what did you say? T cubed over 3. Yes, I heard you saying that. And then what is the integral of 30? 30t, because what gave you 30 when you differentiated? 30t. Then don't forget plus c, but not to match with the previous c, let's call it c2. So this is family of solutions for all kinds of distances. As you can see, family of velocities were again parabolas. This time can't give up actually. So in this case, there were all kind of parabolas looking like so. A family of parabolas. Again, 2t squared plus c is parabola. But in this case, are cubic functions. Cubic functions look like chairs, and they just keep shifted, up and down, up and down. To locate the one we need, we're going to use initial value. The moment we fix the point, the particular solution is chosen. So it's going to be 2a. We need to have s at 0 in order to find c2. I'm going back and I see that s of 0 is given. They were not even lazy to point it out as the equation. They say initial position is, and then they actually wrote it down. S at 0 is 5. So when they were looking at the object, at 0 time, the object was 5 feet away. 5, this is given, and it's called initial value. But s at 0 is going to be 0 cubed plus 30 times 0 plus c2. And that it is supposed to be 5. Solving for c2, it gives me 5. So the general solution of, actually it is called the general versus particular solution. The particular solution in this case for any t is going to be 2/3 t cubed plus 30t plus 5. Put this in the box. So from acceleration, we were able to find family of solutions of velocity and then family of solutions of distance, but then we had to use initial value for each to solve initial value problem. Yes?
Could you still find c if they give you a different value that is not the initial one?
Yes, actually it's a great question. You should understand calling it initial doesn't mean it's 0. So they can tell you that, oh, I saw at 35 seconds, it was 153 to 1, whatever. And that's when you're going to go from that. It's still called initial because the code, okay, at this moment I just noticed this number. It's not necessarily 0, it's mostly 0. But again, when you talk with bacteria cannot show up from 0 bacteria. You need to have at least 1 bacteria. Rabbits, reproduction of rabbits population, you need to have at least 2. Different female and male. Yes. And so on. So like it depends on what you're studying. Yeah. But
so it can be any other point.
Yeah, any point. It can be any here or here and so on. What do you think, people? Questions about this? This is actually something students are good at. So we usually put this in the tests and people do pretty well. But how do you feel about it? Let's practice one more thing, and I think it's going to be good. Example number 3. No contest. It just says solve context. No context. Solve initial value problem. Solve initial value problem. And it says we give you a derivative of some kind of function. Oh, let's call it something interesting. What's your favorite letter in English? Choose a letter. E. We just used S. Choose. Anyone? Choose a letter. B. Yeah, B is good. Let's do B. B. Why so hard to choose a letter? Mine is J, obviously. B prime at time t was 4 square root of t minus 7. And then initial value should be given. So B at 4, just like what you asked, it's not 0 anymore, is 9. This is called initial value problem with the given initial value. B. You can make up what B is if you want. How many bubbles there are in your bathtub at time t, right? Solution. How do you guys, Chris, how do you find B of t?
You just integrate the initial function.
Initial function, 4t minus 7. Good job. dt. Now let's practice integration. I don't think you guys know what is the integral of 4 square root of t. But you can take a pencil and rewrite this as 4 and what? Plus, just t to the 1/2 first. And now we're integrating. So again, if I did not integrate, integral sign stays. So the integral will be 4 t to the 1/2 minus 7. It's still the integral. I did not integrate yet. I'm just rewriting it for my brain to identify power rule better. My brain now sees, oh, this is actually an example. 4t 1/2 plus 1, not minus anymore, divided by whatever it is, 1/2 plus 1. What is minus 7t? Minus 7? Minus 7t plus c, don't forget about that. Let's rewrite nicely. It's going to be 4 over, or times. Let's calculate, take a pencil and calculate. 1/2 plus 1 is what? 3/2. So I'm dividing by 3/2 as well. You see, you don't have to calculate it twice. It's the same number. So I'm multiplying by 2 over 3, exactly. Good job. So it's going to be t to the 3/2 times 4 times to the 2/3 minus 7t plus c. Before you plug in initial value, you can always check yourself by differentiating, but I'm not going to do that. But if you do, 3/2 goes down and cancels out with 2/3. So that's how it all undoes each other. 4 times 2 is 8/3 t 3/2 minus 7t plus c. So that's a family of polynomials shifted by c up and down. This is the first step of the initial value problem. The second step, as always, solve. No, let's find. Let's do find. Find c using initial value. We found b at t. So we need to locate in our task, given b at some number. And it is there. B at 4 is 9. b at 4 is 9. This is given. This is called initial value. Initial value. At 4, when I plug 4 into b, it should give me 9. So that helps me to solve for c. But b at 4 is 8/3 times 4 raised to the 3/2 minus 7 times 4 plus c. And this should be 9. So I plugged 4 everywhere I see t, and the answer should be 9. Solve for c, this side of the equation. Well, 4 raised to the 3/2 is the square root of 4 raised to the 3rd power. So it's going to be 2 times 2 times 2, which is 8. So it's going to be 8/3 times 8 minus 7 times 4. 28 plus c equals to 9. c is 9 minus 8 times 8, 64 over 3 plus 28. And if I did not mess up, it should be 47 over 3. Create common denominator. So, answer. Well, they never ask us to find c. They ask us to find the equation of b. So we need to write down the final beautiful answer. b of t is 8/3 t to the 3/2 minus 7t plus 47 over 3. This is a solution of the initial value problem with the given function and the initial value. So 3 examples, and this is the answer of your question. A question, can initial value not be 0? Good job, people. Have an amazing weekend.